All right, slide 13 is going to be a reminder of how to solve for elastic collisions from the frame of reference of the center of mass of the system. So it's 4 parts. It's essentially the 4 parts that we need to go through to figure out what the final velocities will be after the collision. So part 1 has us finding the speed of the center of mass. Technically, all right, well, let's go ahead and just solve for it. So the velocity of the center of mass, we'll call that VCM. That's going to be equal to the total momentum of the system divided by the total mass of the system. You can treat it like an inelastic collision. So what we're going to do is we can go ahead and take mass 1 times its velocity, which is going to be negative 7.6, plus our other mass, which is going to be positive. That's 4 kilograms times positive 3.2. All of that divided by, the sum of the masses. And so the sum of our masses will just be equal to 2.5 plus 4. Okay. So that's going to give me an answer for the velocity of the center of mass. VCM will be equal to negative 0.9538. And let's throw one more, 5. All right, and that's meters per second. That is the velocity of the center of mass. The question is not asking for the velocity of the center of mass. So if you just put your answer, you're going to get it wrong. Always, before you put in your number, make sure you go back and you check what the question's asking for. It's asking for speed. It wants the speed, which is scalar. So your answer is going to be the absolute value. Velocity is negative. Speed is absolute. All right, moving on to part 2. We're going to find the velocity of each block from the frame of reference of the center of mass. Okay. So if you recall, to find, we'll call this, this is V2 cm. And then in red, that's V1 cm. So the equation to accomplish this was really simple. All we have to do is just subtract out the velocity of the center of mass. So this is equal to V2 minus VCM. And on the other side, V1 cm would be equal to V1 minus VCM. Now, again, this equation is calling for the velocity, not the speed. So let's plug in those numbers real quick. Okay, so jumping ahead, plugging in our numbers, we're going to get our velocities from the frame of reference of the center of mass. So this will be our answer for part 2. Again, making sure to plug in the negative that came from part 1. Now for part 3, the whole reason why we are doing this is because it's really easy to find the final velocities from the frame of reference of the center of mass. All we have to do is take our previous answer and make it negative. So if I want to find V2 cm prime, which is the velocity afterwards, is going to be the same magnitude, just the opposite direction. So this will be negative 4.15385. And likewise, if I want to do the same thing for V1 cm, V1 cm prime, V1 cm prime, that would be equal to, the opposite sign would be positive 6.64615. And those would be my answers for part 3. For part 4, what we're doing is just taking it out of the frame of reference. So to find V2 prime, that's going to be equal to just the opposite of what we did before. So instead of subtracting VCM, we're going to add VCM. So I'm going to take my V2 cm prime, and I'm going to add on VCM, the velocity of the center of mass. And likewise, we'll do the same thing for V1 prime. That would be equal to V1 cm prime plus VCM. All right, so let me plug in those numbers and jump ahead. Okay, so that will give us velocities of V2 prime being negative 5.1077, and then V1 prime being 5.6923. And that's it.